In this video, we want to look at briefly transformers. A transformer is a device used for increasing or decreasing an AC voltage. Now, how we construct them is two coils are wound around a core magnetic material, and on this side what we have is the primary turns. Then this side again is secondary turn. So the primary coil of the primary turns is connected to an AC voltage which produces a time varying current, which is we have primary current on this side in this primary coil. This primary current produces time varying magnetic flux with respect to time. Okay, in the core, in this place now, upon which both the primary and secondary coils are wound. Now, this changing magnetic flux induces an AC voltage on the of the same frequency in this secondary coil. So we have a relationship that says that the secondary voltage over primary voltage is equal to secondary turns over primary turns, equal to then inverse primary current over secondary current. This question says a transformer has 1000 turns on the primary windings and 100 turns in the secondary windings. If the voltage of 250 volts is applied to the primary windings, what will be the secondary voltage of the transformer? So let's break the question down. The transformer has 1000 turns on the primary winding, so that's turns. Primary turns is 1000 turns, and 100 turns in the secondary winding. If the voltage of 250 volts is applied in the primary, so primary voltage is 250 volts, what will be the secondary voltage? So Vs. Now remember the equation we have, that Vs over Vp is equal to Ns over Np. For this question, what we have? So for this question, we'll stop here because this is what we just require. So we can now fix or plug in the values. Vs over Vp 250 is equal to Ns 100 over Np 1000. So here what we have, if we cross multiply, we have, first of all, let's reduce it. We have 100 Vs is equal to 250 times 10, so that 100 Vs is equal to 2500. So that we have that Vs is equal to that secondary voltage is equal to 2500 over 100. This cancels this, this cancels this, so secondary voltage is 25 volts. Now we have two types of transformer. We have the step up transformer, we have the step down transformer. When light leaves the source, when electricity leaves the source, it doesn't enter your house directly. It stops as the transformer if it's not up to the required in your house, in your room, the transformer will step it up to the required voltage that you would need. If it is over voltage, instead of blowing up your appliances, the transformer will step it down to the required voltage in your house. So this question says a transformer has 400 primary turns, so primary turns 400, and 1800 secondary turns. which is this. The input voltage is 12 volts, so primary voltage 12 volts, and the output current is 3 ampere, that is this secondary current when connected across a resistor. What is the output voltage? What is the output voltage? Now, remember the formula we have, that NP over NS is equal to VP over VS, is also equal to IS over IP. So on this case now, for us to get the output voltage, we're just going to pick only here. We'll just say NP over NS is equal to VP over VS. So if we fix the values, our NP is 400, and we're going to pick NS, which is 1800, is equal to VP, which is 12, over VS, which we don't know. So if we make VS subject of the formula, it means we're going to multiply this and divide by this. So we have 1800 times 12 over 400, and if we have that, we're going to have 54 volts across the resistors. Now the second one says we should determine the input current, which is the primary current. We can pick here and say NP over NS is equal to IS over IP. So because here and here are equal, here and here are equal, so depending the parameter given to you in the question, if we fix the values, our NP is 400 over our NS is 1800 is equal to our IS, remember, is 3. So we say 3 over our IP, we don't know. If we make IP subject of the formula, our IP will be equal to this and this times this times this, which is 1800 times 3 divided by 400. If we compute that, we'll get 13.5 ampere. So the other one, another question there says, what is the value of the resistor? What is the value of the resistor? Now, we know that from Ohm's law, we know that V is equal to IR. So what we are using is the secondary to calculate for this. If we now make R subject of the formula, R becomes V over I. That's what we're going to use. And remember, our VS 54 and our IS is 3. So if we divide that, we're going to get about 18 ohm. 18 ohm. The last question there, let's use here. The last question says, what is the power? How much power is dissipated? How much power is dissipated by the resistor? Now we know that power P is given as I squared R. So our I now that we're going to use is 3, the output. So 3 squared times the R is 18, which is 18. This already is 9 times 18. So our power is 9 times 18 gives us 162. Power is measured in watts. So remember to subscribe to my channel if you haven't done that, just by clicking the subscribe button. You can also leave your comment in the comment section if you have any question. Do well to also share this video to your friends. Thank you.